First, I layered a piece of plastic with Scotch packaging tape on both sides. This allowed me to keep the sliding surface a control variable. I separated it with masking tape. I then used a BCA inclinometer on the side so I can watch the slope. Now we need two 87-gram samples of powdered sugar. This will represent fresh snow, what we want to be skiing. Next, we get 26 grams of regular sugar. This will represent facets. Now we'll layer powdered sugar on the side with the inclinometer. This represents fresh, good snow on top of an ice crust with no weak layers beneath it. We'll spread it around to keep it uniform throughout. On the other side, however, we'll first layer granulated sugar on top of the ice crust. This represents facets on top of an ice crust. Now we'll come with our 87 grams of powdered sugar and layer it all over. Again, we'll move it around to keep it uniform throughout and do the little packing thing to keep the two sides the same. What we have represented now is fresh snow on top of an ice crust and fresh snow with facets beneath it on top of the ice crust. Now let's see how this plays out as we steepen the slope angle of both sides. Remember, faceted layer on the left, regular snow layer on the right with the inclinometer. Boom, there goes the faceted layer, right between 35 and 40, which is what we talked about earlier. Now just for kicks, let's see when there it goes. Right between 50 and 55. Overall, this experiment confirmed two things. The first being that facets on top of an ice crust underneath the snow layer cause big problems in the snowpack. The second thing that this experiment illustrated has more to do with slope angle than anything else. This showed perfectly that 35 to 40 degree range is where problems really occur.